Hi viewers. In last class we saw that what is whole number and what are the properties of whole number. In this class we are going to see what is integers and what its properties. Integers is represented by the letter Z. You know it's negative numbers. It contains negative numbers 0 and positive. Otherwise we can say it as negative and whole numbers. That is nothing but integers. We can represent this number in the number line. How to represent? Center point is 0. This and all positive values, and this left hand side are negative values. If you can take any two numbers from this number line and you want to check whether which is greater and which is smaller, means it's very simple. In left hand side number is always lesser than that right hand side. Suppose if I am taking -4 and -1. I want to know which is greater. You know this -1 is present right to this -4. So -4 is in left hand side. So this is lesser number and this is greater number. From that easily we can find it out which is greater and which is lesser. -3, -1. So -1 is greater than -3. 0 and -4, if you can compare, the 0 is right to this -4. So 0 is greater than this -4. Okay, next we are going to see what are the properties of integers. Same thing what you have studied in that whole numbers, the same main four properties are there. Property, this and all operations on integers. You know, always this four arithmetic operations we have to do to check this properties. Same four property: closure, commutative, associative, distributive. Already I told you that closure means you have to take any two numbers. But here we are going to take out from the integers, because in last class we saw whole numbers, so we taken the numbers from 0 to infinity. But here minus infinity to infinity. In between 0 will be there. That means here and all negative numbers, here and all positive, center is 0. So we are taking any two numbers from this integer. If you can add, it becomes an same integer. So the closure is satisfied for addition, subtraction and multiplication, but not for division. Similarly, if you are taking this commutative, that is a plus b is equal to b plus a. Commutative means only these two numbers you have to take. Associative means you have to take three elements. 2 means even if you can interchange their position, the value does not get changed. So that is nothing but a commutative. This is for addition. And for subtraction it does not satisfy. Why? If I am taking 3 minus 0, here 0 minus 3. Here the 3 minus 0 is 3 only. But 0 minus 3 is minus 3. So 3 is not equal to minus 3. So here this commutative not satisfied for subtraction and also for the division. Similarly associative. Associative means always you have to take three numbers. Commutative means two elements. So a plus b plus c, that will be equal to a plus b plus c. Even if you can interchange their position, the addition value does not get changes. But in subtraction it gets changed. In multiplication it does not change. But in division also it does not satisfy. Okay, distributive. Like that in that last whole numbers. Here also is over addition and over subtraction alone here. But it's not applicable for multiplication and division. Now we are going to see the problems based on this integers. Before that, one more thing we should know. What is that means? In last class we saw that additive identity, multiplicative identity for the whole numbers, no? Same thing. Here also additive identity for this integers is 0 and multiplicative identity is 1. You know what do you mean that additive? If you can add 0 with any number, you will get the same number. So what number if you can add with this to get the same number? 0. Multiplicative identity means is nothing but by multiplying which number you will get the same number. So 1 only. So here also the multiplicative identity is 1. Additive inverse. What do you mean that additive inverse? Whatever the number if you can take, you can add its opposite number to get the value as 0. That is nothing but additive inverse. For an example, if you are taking -5, to which if you can add plus 5, it becomes a 0. So what is the additive identity of minus 5? Plus 5. Plus 5 is an additive inverse. Similarly, if you are taking 7, what is the additive inverse of plus 7? Minus 7 is the additive identity. Sorry, it's an additive inverse. Because if you are adding this number, then only you will get the 0. If I am taking minus 25, what is the additive inverse of this minus 25? Plus 25. So this is nothing but additive inverse. Now we are going to see that addition table and multiplication in that integers. Plus in plus plus plus. See, if you are adding two plus numbers, the resulting should be a plus. If you are adding two negative numbers, the resulting should be a plus. But you have to put the negative sign. So I will just say it in an example. If you are adding two positive number plus 12, if you are adding two negative numbers, whenever you are seeing two negative, you can add but put the negative sign. If it is positive, you need not to put the sign. If it is negative, you should put the sign. One negative, one positive. See, minus 5 plus 7. If one is negative, one is positive means surely you have to subtract and you have to put the sign from which number you are subtracting. That sign you should put. So from 7 only we are subtracting 5. So plus 2. Here 5 minus 7. You know we are subtracting from 7 only this 5. Is it? So from 7 means the 7 has the negative sign. So in our answer should contain this negative sign. So plus plus plus. If it is negative, both are negative, add and put the negative sign. 1 plus 1 negative means in our answer put the sign from which number you are subtracting. That is that main thing. And multiplication table. Plus and plus multiplication, it becomes a plus. And then plus into minus, it's become minus. Minus into plus, it's become minus. If both are negative, if you can multiply, it's become a positive. How to see it in that example? You can see 6 into 3, 18. Both are positive. So that answer is positive. Here 6 into minus 3. One is positive, one is negative. So your answer should contain this negative sign. Here also minus 6 into plus 3. Here is minus, here is plus. So if you can multiply, you are getting negative sign. If both are negative, the answer is positive. So which should have that positive sign? If both are positive, if both are negative, the answer becomes positive. But in addition, if both are negative, your answer should contain the negative sign. That is an important difference between this and this. And division. As per the same as multiplication rule, both are positive means positive sign. Both are negative means positive sign. Because this minus minus gets cancelled here. But one positive, one negative number, if you are dividing here, that answer should contain the negative sign. In subtraction, if you can see here, 15 minus of minus 15 means whenever the bracket is given, first you have to remove this bracket. How to remove? The outer sign and innermost sign you should multiply. Make it as a simplify this. So minus into minus plus. So 15 plus 15 is 30. Minus 2 plus of, you have to read it as half of minus 5. Whatever that number is in bracket, you should multiply. Plus into minus, minus. So already is minus 2. Now this becomes minus because plus into minus, minus 5. So minus 7. Suppose more than 2 numbers are given. How to do? Minus 10, minus 5, plus 5, plus 3. This type of numbers, see I am given is only a single digit. The same rule will be for double digit or triple digit, whatever it may be. Minus, minus. So first you can club the negative signs, then you club the positive signs. So minus 10, minus 5, it's become minus 15. Plus 5, plus 3, it's become plus 8. So if you are adding one negative, one positive means automatically you have to subtract it. Subtract. But after subtracting, from which number you are subtracting, that sign you should put here. So minus 15 plus 8, it's become minus 7. Not plus 7 because we are subtracting from 15. The 15 has this negative sign. So we have to put the sign from which number we are subtracting. Is it clear to you all? Thank you. Thank you for watching.